So as an example, let's think about a situation like this where I have, say, samples 1, 2, 3, 4, 5, 6, 7, and 8 with observations, single observations, samples of size 1 that for sake of argument happen to be 5, 3, 9, 10, 17, 4, 6, and 2. Now, if it's the case that rational subgroup size, natural sample size, is only 1, that is, if it's the case that it makes no sense to think of the 5 and the 3 as belonging to, or is guaranteed to come from the same set of process conditions, or the 5 and the 3 and the 9 is guaranteed to come from the same set of process conditions. If I'm stuck with samples of size 1, what can I do about control charting? So, what to do about short control charting? Well, the most obvious thing to do is to plot the x's. That is, I can go ahead and plot the 5, the 3, the 9, the 10, the 17, the 4, and the 6. How should I think about control limits for those x's? Well, those individuals, so this is x, this is individuals, those individuals, you could think of them as x bars based on samples of size 1. That is, if I only have one observation, I add up one thing, I divide by 1, I have an x bar. So with that kind of thinking, possible control limits for the x's would be the mean for a sample average of size 1, that's just the process mean, minus 3 standard deviations for a sample average of 1 observation. Well, that's just the process standard deviation. Similarly, an upper control limit for x, a reasonable choice would be to use mu plus 3 standard deviations as a upper control limit for individuals. Truth of the matter is, this is the right thing to do. That's pretty much all that there is in this problem. That is, plot individuals, use control limits, process mean, minus 3 standard deviations of the process mean, plus 3 standard deviations for the process. That's the rational thing to do. Having said that, another possibility generally a bad one, is to also plot moving ranges. Okay, what do I mean by a moving range? Well, by the ith moving range, what I mean is take the ith observation, subtract the previous one, and take an absolute value. If I come back to this data set here, I could put in moving ranges this way. There's no moving range for sample number 1, but the difference between the 5 and the 3 is 2. The difference between the 3 and the 9 is 6. The difference between the 9 and the 10 is 1. The difference between the 10 and the 17 is 7. The difference between the 17 and the 4 is 13. The difference between the 4 and the 6 is 2. The difference between the 6 and the 2 is 4. And operating from a desire to have something like a R chart to go along with the individual's chart, it's reasonably common for people to think about control charting these things, control charting those moving ranges. Let me say to you again that this turns out to be not a really smart thing to do. But a possibility would be to plot moving ranges. What would I use for control limits for moving ranges? Well, typical practice is to use an upper control limit for moving ranges that is based on a quote-unquote sample size of 2 and is big D2 times the process standard deviation, where this thing is based on not really a sample size but a pseudo sample size of 2. The idea being that I've taken into account 2 observations when I make up every moving range. As it turns out, as I say, this is a bad idea. This turns out to have a huge false alarm rate. Okay, by false alarm rate I mean small ARL, when all is really okay. And as a matter of fact, instead of being something like 370, it's more on the order of 100. So a reason not to do this is that it typically produces all kinds of false alarms. It's just not a very wise thing to do.